Have you ever wondered what lies beneath your feet deep within the earth? It's a question that has captivated the minds of scientists, researchers, and curious individuals alike for centuries. As we go about our daily lives, we're standing atop a world of mysteries, a planet that holds secrets deep within its core. Imagine peeling back the layers of an onion. The Earth, much like that onion, is composed of various layers, each unique and pivotal to the planet's overall structure and function. These layers, extending from the crust through the mantle to the outer and inner core, hold the key to understanding the Earth's past, present, and potential future. And yet these layers are not just layers of rock and metal, they are time capsules, holding answers to some of our most profound questions. What are these layers made of? What processes occur within them? How do they shape our world? Join us as we embark on a journey to the center of our planet. Starting our journey, the first layer we come across is the Earth's crust. Now you might be thinking, it's just soil, but let's not be hasty. The Earth's crust is so much more than just dirt. It's a complex and diverse layer that plays a vital role in supporting life as we know it. This layer, the Earth's skin if you will, is composed of a variety of elements. The most abundant of these are oxygen and silicon, making up about 46% and 28% respectively. Other elements like aluminum, iron, calcium, sodium, potassium, and magnesium also contribute to its composition, forming a diverse array of rocks and minerals. But the Earth's crust isn't just a static layer. It's split into large pieces known as tectonic plates. These plates, floating on the semi-fluid layer of the upper mantle, are constantly in motion. And when I say constantly, I mean over millions of years. It's a slow dance, with these plates moving just a few centimeters each year. These movements, though slow, have dramatic effects. They cause earthquakes, form mountains, and even create new ocean floor. The interactions between these plates shape our landscapes, giving us the diverse geography we see today. The crust also acts as a barrier, protecting us from the extreme heat and pressure of the Earth's interior. It's the foundation upon which we build our homes, grow our food and mine for resources. Without it, life as we know it would be impossible. The crust is also home to the biosphere where all known life exists. From the highest mountains to the deepest parts of the ocean, life thrives within this layer. It's a testimony to the incredible resilience and adaptability of life. So the next time you're out and about, take a moment to appreciate the ground beneath your feet. It's not just dirt, it's a living, breathing layer that's constantly changing and evolving. Despite being the thinnest layer, the Earth's crust plays a pivotal role in our lives. Beneath the crust lies the largest layer of the Earth, the mantle. This colossal layer, making up a whopping 84% of our planet's volume, is more than just a massive blanket beneath our feet. It's a hotbed of geological activity, responsible for creating and altering the landscape we see today. The mantle consists primarily of silicate rocks rich in magnesium and iron, which, under the immense pressure and heat, behave more like a viscous fluid than a solid rock. This heat is not just residual warmth from the planet's formation over 4.5 billion years ago. It's continuously replenished by the decay of radioactive isotopes like uranium and thorium. Now, imagine a pot of soup simmering on the stove. As the soup heats, it rises to the surface, cools down, then sinks back to the bottom, creating a circular motion. This is similar to what happens in the mantle, a process known as convection. The intense heat from the core warms up the mantle, causing it to rise towards the crust. As it nears the surface, it cools down and sinks back towards the core, creating a continuous cycle of convection currents. These currents don't just stay confined within the mantle. They have a profound impact on the Earth's crust, specifically the tectonic plates. The convective forces push and pull these plates, causing them to move. This movement is responsible for earthquakes, volcanic eruptions, and the creation of mountain ranges. So next time you marvel at the beauty of a mountain or feel the ground shaking beneath your feet, remember the mighty mantle beneath us. The mantle isn't just a passive layer of hot rock, it's a dynamic and active part of our planet, a veritable engine that powers the Earth's geological processes. It's the reason our planet is not a stagnant, motionless sphere in space, but a vibrant, living world that's constantly changing and evolving. The mantle, with its intense heat and pressure, is a powerhouse driving the Earth's dynamic activities. Descending deeper, we reach the Earth's core, a region split into two parts, the outer and the inner core. This is where the real action happens, where the magic of Earth's magnetic field is churned into existence. But let's not get ahead of ourselves. The outer core, the first layer we encounter, is a sea of molten iron and nickel, swirling around the planet's center. It's a bit like a planetary lava lamp, but this one is under incredible pressure and reaches temperatures up to 5,000 degrees Celsius. That's hotter than the surface of the sun. This fiery ocean extends about 2,200 kilometers, a distance roughly equivalent to a road trip from New York to Dallas. But unlike a road trip, we're talking about a journey straight down through a roiling sea of liquid metal. Imagine that. Next, we delve into the inner core. Unlike its outer counterpart, the inner core is a solid sphere, again primarily composed of iron and nickel. You might wonder, why is it solid? Isn't it hotter there? You'd be right. The inner core is indeed hotter, reaching temperatures up to 6,000 degrees Celsius. However, the pressure here is so immense that the metals are squeezed into a solid state. The inner core is about 1,200 kilometers in radius. That's about the distance from Los Angeles to Denver. It's a relatively small region, but it plays a massive role in our planet's functioning. Now, let's talk about the Earth's magnetic field. Both the outer and inner cores are crucial in generating this field. The outer core, with its molten iron and nickel, creates an electric current as it moves. This motion is driven by Earth's rotation and the fact that the bottom of the outer core is hotter than the top, creating a process called convection. The electric current, in turn, generates a magnetic field. This field gets strengthened by the solid inner core as it spins slightly faster than the rest of the planet. This phenomenon, known as the geodynamo, creates a protective shield around the Earth, deflecting harmful solar radiation. Without this magnetic field, life as we know it would not exist. The field not only shields us from solar radiation but also helps maintain our atmosphere by preventing solar winds from stripping it away. So while the core may be hidden deep beneath our feet, its effects are felt every day. It's a testament to the interconnectedness of our planet and the delicate balance that allows life to thrive. The Earth's core, a place of extreme conditions, is the heart of our planet's magnetic field. Truly, it's not just about what's on the surface that counts, but also what lies beneath. Our journey to the center of the Earth has brought us face to face with the fascinating layers beneath our feet. We've delved into the mysteries of our planet's interior, finding a world far more complex and intriguing than one could imagine. First, we encountered the crust, the Earth's outer skin. It's a thin layer, a mere fraction of the Earth's total size, yet it's where all life as we know it exists. The crust is made up of various rocks and minerals and is divided into tectonic plates, whose movements shape our world's geography. Beneath the crust, we found the mantle, a thick layer of hot, flowing rock. This isn't molten rock, but solid rock that flows under immense pressure and heat. It's the movement of the mantle that drives the tectonic plates of the crust, leading to earthquakes and volcanic activity. And at the heart of it all, we discovered the Earth's core, split into two distinct parts, the outer and inner core. The outer core, a sea of molten iron and nickel, creates the Earth's magnetic field. Beyond it lies the inner core, a solid ball of iron, under such extreme pressure that it remains solid, despite being hotter than the surface of the sun. Each of these layers plays a vital role in making our planet what it is today. They interact in complex ways, influencing everything from the movement of continents to the creation of mountains and oceans. So we've journeyed from the familiar ground beneath our feet to the very heart of our planet, exploring the intricate layers that make up the Earth. We've seen that beneath our feet lies not just dirt, but a dynamic and ever-changing world, playing out its drama far beneath our notice. So the next time you walk on the ground, remember you're walking on just the tip of a fascinating world that lies beneath.